Welcome to the presentation of our paper titled Screenless Interactive Tabletop Gaming with Capacitive Surface Sensing. In this work, we show how capacitive sensing can be applied to augment tabletop board games without compromising tangibility. We also show that this can have a positive effect on beginner players. The integration of technology into board games is a promising area of study. Overhead projectors, electrochromic displays, and interactive tabletops have been proposed to display essential game information. However, past studies suggest that such solutions may also distract the player from the core gameplay. Traditionally, tabletop gaming is a manual activity, often burdened with laborious bookkeeping actions. These can detract players from the core of the gameplay, which may reduce performance and lead to a less enjoyable gaming experience for beginner players. Our work contributes the following. 1. A screenless tabletop game piece tracking system for enhancing tabletop games. 2. An empirical user study to evaluate the influence of our system on gameplay. 3. Practical insights to guide the future of augmented board games. Previous work that analyzed player experiences of augmented board games showed that bookkeeping was often causing trouble and could be automated. With this in mind, in our study, we chose to augment a game titled Photosynthesis. It is an action point strategy game during which players have to manage the growth of a forest in a competitive environment. Most importantly, the game has non-trivial rules for obtaining points that are based on the geometry of shadows cast by trees. The players have to repeatedly apply these complex rules in each round to determine how many points they should add to their score. To reduce the bookkeeping burden on players, we constructed a system that automates counting points in Photosynthesis. We achieved this by replacing the analog point counting board with a simple digital dashboard. Points displayed on the dashboard are automatically updated without the need for manual data entry. In order to preserve the game's tangibility, we repurposed an off-the-shelf, multi-touch capacitive sensing foil to detect placement of the game pieces without additional hardware. The original pieces for Photosynthesis are made out of cardboard and do not cause detectable changes in capacitance. To solve this problem, we designed a set of conductive markers. Each piece type has a corresponding marker shape. Different shapes produce different patterns of capacitance change, which allows for identifying the game pieces. Markers were 3D printed from a conductive filament and attached to the base of the original cardboard pieces. Now, let's quickly go through the data processing pipeline used for point counting. First, a piece equipped with a conductive marker is placed on or removed from the sensing surface. Next, the conductive marker attached to the piece produces change in the measured capacitance. The pattern of the change is unique to the marker's shape. Our algorithm detects the change, assesses if it is strong enough, and triggers further processing. A support vector classifier is used to determine which piece type has been placed on a given gameboard field. We apply additional filtering to reject hand touches and measurement artifacts. Additionally, we conduct voting across 3 consecutive samples to reduce errors. Classifier predictions are then used to detect player moves by comparing the current gameboard state with the previous state. The detected moves are passed on to the digital game implementation, which is responsible for computing player scores. Here are examples of game actions detected by the system. Purchasing pieces from the store. Growing trees. Collecting sun points. We conducted a user study to determine the effect of using our system on the gameplay. 20 participants with no previous experience of playing the game were recruited. The study had 2 conditions and followed a between-subject design. In the first condition, participants counted points manually. In the second condition, automated point counting was used. Games were played in pairs and lasted 12 rounds. We recorded all sessions from 2 viewpoints for further analysis. 2 researchers were present during the study. Researcher 1 was supervising the point counting system, and Researcher 2 was supervising the game. In the condition with automated counting, points were displayed on a tablet placed on a table next to the game board. We extracted game round durations by analyzing the video recordings from the experiment. Our analysis showed that, despite delay between the move and point dashboard update, on average, the rounds played with automated point counting were shorter than the rounds played with manual counting. We also counted each type of action performed by the participants to characterize their gameplay dynamics. We found that when using an automated point counting system, players planted fewer small seeds and purchased fewer small trees. Because the game mechanics penalize planting large numbers of small trees and seeds in short games, we conclude that the participants playing with the system adopted a more effective strategy. At the end of the game, we conducted individual debriefing interviews with the participants. We built 3 themes which describe the gameplay: level of interference, struggles during gameplay, and technical considerations. The analysis yielded the following insights. Augmented board games which interfere too much with the gameplay can impede immersion. The participants frequently struggled to understand the rules of newly introduced games and wanted interactive systems to solve this problem. While the participants praised the tangibility of the system and liked the automatic point counting, they found the high response time of our system annoying. Conclusions. 1. We present an automatic point counting system designed to enhance tabletop board games. 2. We tested the effect of the system on gameplay using the game photosynthesis as an example. Feedback from participants indicates that our prototype did not disrupt gameplay, but instead improved focus on game mechanics, enabling players to develop more effective strategies. 4. Our study highlights the potential of capacitive sensing to improve player experience by augmenting tabletop board games. Thank you for your attention.